Have you ever stopped in your tracks when the rain clears and suddenly a rainbow stretches across the sky? It feels almost magical, doesn't it? That perfect arc of colors glowing after a storm has fascinated humans for thousands of years. Poets, artists, and storytellers have all tried to capture its mystery. But here's the real question. What actually makes a rainbow appear? Stay with me until the end, because by the time we finish, you will understand not only how a rainbow is formed, but also why its beauty hides one of the most fascinating tricks of light and water in nature. You'll never look at one the same way again. Let's start with the most basic part: sunlight. At first glance, sunlight looks white. It shines on your skin and on everything around you, and you don't think twice about it. But sunlight isn't really just one color. It's a mixture, a blend of all the colors of the visible spectrum. Inside that beam of light are reds, oranges, yellows, greens, blues, indigos, and violets, all traveling together. They're usually hidden, packed neatly into what we perceive as white. And the rainbow is the moment when nature splits that light apart for us to see. Now imagine raindrops falling from the sky. Each tiny drop is round, smooth, and transparent. You could think of it as a miniature glass sphere floating in the air. When sunlight enters that drop, something fascinating happens. The light slows down because water is denser than air, and as it slows, it bends. This bending of light is called refraction. It has the same effect you see when you put a straw in a glass of water and it looks bent at the surface. But in a raindrop, the bending doesn't stop there. After entering the droplet, the light reflects off the inside surface, then exits again. And when it exits, it bends once more. That journey of bending and reflecting is what spreads the colors apart, fanning them out into the spectrum. But why do the colors separate instead of all staying white? The answer is because different colors of light bend by different amounts. Red light bends less, violet bends more. So inside each droplet, the white light is split into a band of colors. That means every single raindrop in the sky is producing a tiny rainbow. But you don't see all of them. You only see the ones that happen to send the separated light directly to your eyes. It's as if millions of drops are holding up mirrors, but only the ones at the right angle reflect back to you the rainbow you admire. And this is where it gets even more interesting. A rainbow is not an object hanging in the sky. It doesn't exist in a fixed spot that everyone sees the same way. It's actually a circle of light centered around the line between your eyes and the sun. You usually see only half the circle, the arc, because the ground blocks the rest. But if you were in an airplane with rain below you and the sun behind you, you could see a full circle rainbow. It's there, but only from that special perspective. So the rainbow is personal. The one you see is not the same rainbow your friend sees standing a few feet away. Each of you is looking at light coming from different sets of raindrops. In a way, every rainbow is your own rainbow. Think about that for a second. When you stop to take a picture of a rainbow, no one else has exactly the same image. That shimmering arc is unique to your eyes and your position. That's one of the reasons it feels so magical. It's like the sky is painting a gift just for you. Now, why does a rainbow appear after rain and not during every sunny moment? The trick is the combination. You need the sun to be low in the sky, usually in the morning or late afternoon, and you need raindrops still hanging in the air. The sun has to be behind you, shining into the drops ahead of you. If the sun is too high, the angle isn't right, and the rainbow disappears. That's why midday rain rarely gives you a rainbow. Timing and positioning matter as much as the rain itself. But the rainbow you see most often is just the primary rainbow. There are more secrets hidden in the sky. Sometimes, if you look carefully, you'll notice a second, fainter arc outside the main one. That's called a double rainbow. It happens because light can bounce twice inside the raindrop before it exits. With two reflections, the colors are reversed, red on the inside instead of the outside. The second arc is dimmer because some light escapes after the first bounce, but when you see it, it feels like nature is doubling the spectacle. And even beyond that, there are rare rainbows caused by moonlight, called lunar rainbows, which are pale and ghostly, often white to our eyes, because they're too faint for us to see their colors clearly. There are even supernumerary rainbows, thin bands of extra colors that appear inside the main arc, caused by the wave nature of light. But let's not get lost only in the physics. Rainbows are also stories. Ancient cultures tried to explain them long before science did. In Norse mythology, a rainbow was the bridge between Earth and the realm of the gods, called Bifrost. In Irish folklore, leprechauns hid pots of gold at the end of rainbows, even though, in reality, a rainbow has no end. In many cultures, rainbows symbolized hope, peace, or messages from the heavens. The science explains the mechanism, but the wonder explains why humans gave them meaning. Let me give you a small, everyday example that ties this science back to your life. Have you ever seen colors dance on a soap bubble? That rainbow shimmer on its surface is created by the same principle: light, bending, splitting, and interfering. Or when you hold a prism up to the light and see it scatter into colors across the wall, you are holding a tiny rainbow in your hand. The phenomenon of dispersion, where light splits into different wavelengths, is not rare. It's around us all the time. The rainbow in the sky is just the most grand and spectacular version. Another fascinating detail is why rainbows always show colors in the same order. Red is always on top, violet always at the bottom. That's because of the way the light is bent inside the raindrops. The red light exits at a slightly higher angle, about 42 degrees, while violet exits at about 40 degrees. Those 2 degrees make the difference between top and bottom, and every other color fits in between. The order is locked by the physics of light itself. So whenever you see a rainbow, you're not just seeing random beauty. You're seeing mathematics and physics drawn in the sky. And yet, there's still something elusive about it. You can chase a rainbow all you want, but you'll never reach it. It's always tied to your position relative to the sun and raindrops. Move forward, and the rainbow moves too. It can't be touched, it can't be caught. It exists only as long as the conditions are perfect. That fleeting nature is what makes it so breathtaking. You know it won't last. You know the sun will shift, or the rain will fade, and the arc will vanish. That impermanence makes every rainbow special. Now think about this. Scientists studying rainbows have learned more than just why they shine. By analyzing how light behaves in droplets, they've developed technologies like fiber optics, where light bends and travels through cables, bringing you the internet and phone calls. The same principle that makes a rainbow appear is the foundation of modern communication. Isn't it incredible that something so delicate in the sky has led to breakthroughs in human progress? And rainbows even push the limits of art and imagination. Musicians write songs about them, painters try to capture their glow, photographers chase them after storms. But here is the truth. No painting or photograph can ever fully capture the experience of standing under a real rainbow. The shimmer, the arc, the way it blends into the clouds and light. Your eyes and brain take in the full glory that no camera can truly replicate. That's why, no matter how many times you see one, it always feels new, So the next time you see a rainbow, pause for a moment. Think about the millions of raindrops floating in the air, each acting as a tiny prism. Imagine the sunlight splitting into colors inside them, bouncing, bending, and finally reaching your eyes. Realize that what you're seeing is your own personal rainbow, one that no one else in the world sees exactly the same way. Remember that it is not just a decoration in the sky, but a demonstration of the hidden richness of light, a natural performance of physics, history, and wonder. And let me ask you, did you ever imagine that something so familiar could hide such a complex and beautiful explanation? Now, you know what makes a rainbow appear. It's sunlight, water, and the geometry of nature working together in perfect harmony. It's science, but it feels like magic. If this story sparked your curiosity, share your thoughts in the comments. Tell me about the most beautiful rainbow you've ever seen, and don't forget to subscribe. Because this is just the beginning of many more journeys into the hidden wonders that surround us every day.